In this video tutorial, we are going to focus on converting numbers in binary system to numbers in octal system. What you need to know is that numbers in binary system are said to be in base 2, while numbers in octal system are said to be in base 8. So what are the process? What do we need to go through while converting numbers in base 2 to numbers in base 8? To understand this properly, let's begin with an example. How can we convert this binary number to number base in base 8? So what you need to know is that 3 digits of binary system correspond to a digit of octal system. So which means what we are going to do in excess is to form a bit such that in one bit we are going to have 3 digits. So starting from the right, I'm going to form a bit. This is one, comprises of 3 digits of binary system. This is another one, and this is the last one. So the next step is to convert each of these bits to decimal numbers. And I'm going to combine them together. That will be my solution in base 8. So if you haven't watched my video on how to convert binary system to decimal system, then consider checking out the video that just popped out at the top right hand corner of this video, or you should just check out the video description. So right now, for 101, what I'm going to do is I'm going to assume it's in base 2, and 111 is also in base 2, and 110 is also in base 2. So to convert them, what I will do is to expand each of the digits by the base 1 times 2. Then I'm going to add that to the next one, 1 times 2. So for the next one, which is this, so that will be 1 times 2 plus 1 times 2 plus 1 times 2. I'm going to leave a space as well for the third one, which is this. So that's 1 times 2 plus 1 times 2 plus 0 times 2, for instance. Okay, hopefully you can figure that out. So right now, the next thing I'm going to consider doing is to assign an index to the base, starting from the right hand side, then all the way to the left hand side. However, the index will be starting from 0 as well. 0, 1, 2, 0, 1, 2, 0, 1, 2. With this, I've been able to form a binary, also a octal digits. So right now I will simplify. 1 times 2 to the power of 2 is 4, plus 0 times 2 to the power of 1 is 0 times 2, plus 1 times 2 to the power of 0, that's 1 times 1. For the second one, 1 times 2 to the power of 2, that's 1 times 4. 1 times 2 to the power of 1, that's 1 times 2. And 1 times 2 to the power of 0, that's 1 times 1. And for the third one, 1 times 2 to the power of 2 is 1 times 4. And 1 times 2 to the power of 1 is 1 times 2. And 1 times 2 to the power of 0, 0 times 2 to the power of 0 is 0 times 1. So right now we can see that this will be 4 plus 1, and this will be 4 plus 2 plus 1, and this will be 4 plus 2. So it turns out that this is 5, this is 7, and this is 6. So combining them, it turns out to be 5, 7, 6 in base 8. And this is our final answer. I believe you understand the pattern. You can see how it works. First step, break the binary system or the binary digits into a bit, such that a bit will comprises of 3 digits of the binary digits. Then convert each of those bits to decimal numbers. Just join those decimal numbers according to how the bits are arranged, and boom, that will result in the conversion relative to base 8. Let's consider another example rather. Okay, we are not considering one, we are considering plenty for easy understanding. Number 2. If you haven't subscribed to my channel, please do want to subscribe to my channel. That will help me to reach more audience. So feel free to pause the video and check this question out. How can we convert this to number base in base 8? So just like before, let's form a bit. Within a bit, there will be 3 digits. So this is the first one, starting from the right. This is the second one, and this is the third one. Unfortunately, The third one is unable to reach 3. In a case like this, you had 0. The 0 won't add to your result, it won't subtract from your result, it won't affect your result. But to just be able to have up to 3 digits to make up the bit, that's why we need to introduce 0. Since 0 is an additive value, you understand, it won't affect your solution. So what we are going to do next is to convert each of those bits to a decimal number. So for 111, that corresponds to, you can see that is in base 2, that's 1 times 2 plus 1 times 2 plus 1 times 2. That's 0, 1, 2. Then for 100, that corresponds to 1 times 2 plus 0 times 2 plus 0 times 2. 0, 1, 2. And for 011, that corresponds to 0 times 2 plus 1 times 2 plus 1 times 2. That's 0, 1, 2. Right now, let's find the solution. So this is equals to 4 plus 2, and this, okay, plus 1, and this is equals to 4, and this is also equals to 2 plus 1. So this eventually results in 7, while this results in 4, while this results in 3. Now, please be very careful. Don't go and misarrange the conversion. You are going to arrange them according to how the bit is formed. You can see that towards the left, this is the first bit that occurs. So it means it will be 3, 4, 7 and not 7, 4, 3. Please be very careful with the pattern as well. Don't go and misarrange them. Okay? I believe you grab that. So that's the solution to this problem as well, which means that this in base 8 corresponds to 347. And that's it. So let's get one more example for easy understanding. Hopefully by now you should have understand the pattern on how to convert a binary number to octal number without undergoing a decimal process. So feel free to pause the video and check this question out. Convert this binary number to number in base 8. So just like before, I would like to group this in threes. So let me rewrite it such that there will be no space. Okay. So this is the first bit. This is the second bit. This is the third one. So the fourth one is unable to reach up to 3. So I'm just going to add 0, 0. Okay. For it to be up to 3. And here it is. So right now I would like to convert them. Okay. So for 0, 0, 1, that is 0, 0, 1. So that should correspond to 0 times 2 raised to the power of 2 plus 0 times 2 raised to the power of 1 plus 1 times 2 raised to the power of 0. For 101, that corresponds to 1 times 2 raised to the power of 2 plus 0 times 2 raised to the power of 1 plus 1 times 2 raised to the power of 0. For 111, that corresponds to 1 times 2 raised to the power of 2 plus 1 times 2 raised to the power of 1 plus 1 times 2 raised to the power of 0. And for 010, that corresponds to 0 times 2 raised to the power of 2 plus 1 times 2 raised to the power of 1 plus 0 times 2 raised to the power of 0. So let me simplify my result. So in order to have enough space, I can just add those values together. So this zeros will get rid of since they are being multiplied by 0. And 2 raised to the power of 0 is 1. 1 times 1 is 1. So this is 1. So 1 times 2 raised to the power of 2 is 4. This will get rid of. And this will be 1. That should be 5. So 1 times 2 raised to the power of 2 is 4. 1 times 2 raised to the power of 1 is 2. That's 6. And 2 raised to the power of 1 is 1. That's 7. So for this 0 get rid of, and this get rid of. So the final answer is 2. So therefore, this in base 8 correspond to, since this tends to occur, it means we are selecting them downward like this. So that should be 1572. Increase it, and this is my final answer. As you can see, this is how it works. This will help your work to be pretty much faster instead of going through the other way around, because there's another way to deal with this by converting the binary number to decimal number. Then having done that, you now begin to convert it to octal number again by dividing the decimal number successively by 8. That might be somewhat cumbersome and be very bulky to deal with. This will surely help you, and I believe you should find it comprehensive and interesting. If you haven't subscribed, like I said, please do well to subscribe to my channel. If you find this content helpful, don't forget to give this video a thumbs up and like. So YouTube can know that the video is loved and liked, so they can recommend it to many viewers out there. Thanks for watching. See you guys in the next video. I have an exercise for you to practice with, and here is the exercise. Feel free to comment your solution in the comment section below for review, and I'm going to let you know if your solution is right or not. And that's it. See you guys in the next video. Take care. Bye.